Hello and welcome back. This is day 9 of Advent of Code 2022. Let's get started then. So in this puzzle, there is a rope bridge that creaks as we walk along it. Okay, you are not sure how old it is or whether it can be supported or not. Okay, blah blah blah. So consider a rope with a knot at each end. Those knots mark the head and tail of the rope. Okay, if the head moves far enough away from the tail is pulled away toward the head. Okay. Due to blah blah blah, then by a series of motions like this for the head, you can determine how they will move. Do the plank snake. The ropes must quite be short. In fact, the head and tail must always be touching. Okay, diagonally adjacent and even overlapping, both contacts touching. Okay, so these are touching, and as it covers it's touching. Okay, if the head is over 2 steps directly up, down, left or right from the tail must also move 1 step in that direction so it remains close enough. So like if we are this and then we get this, which is 2 steps apart, then we need to move the tail to get to the head, or like this. Okay, otherwise if the head and tail aren't touching and aren't in the same row or column, the tail always moves 1 step diagonally to keep up. Okay, so in this scenario we are like a chestnut away from each other, so these tails should go up and go right to be underneath the head. Or in this scenario, if H is move 1 to the right, then we need to move T1 to the right and 1 to the up, so it's close to its head. Okay. Then this is the puzzle, and then there is E moving, so TH, EH. I don't need to read this. After simulating the rope, you can count up all the positions the tail visited at least once. In this diagram, S again marks the starting position. Okay, so this has gone like this. There are 13 positions the tail has visited at least once. Simulate this and tell me how many positions does the tail of the rope visit at least once. Okay, so it should be pretty fun. Let's do that then. I am reading the input as always, and then first thing first, I need to map this to be each row, and then split each row to by space, so that I have the direction and the steps apart from each other. Like here, let me get the input like this. So I need to separate these values from each other. So I'm getting this, and I'm coming here, row dot split, and then this. Okay, let me save this and then see what's the input, if I'm getting the input right. So node part 1. So okay, let's do the rest of it then. So what we should do is, for every let's call it walk or something like that of the input, so for every walk that we do, so for example this is a walk that takes place 4 steps to the right. Actually, let me make this a little bit bigger so it's more visible. So for every walk like this or any of them, I need to first get the direction and the steps from the walk. I can do it from this, but I need these to be a number, so I will say walk at index 0 and then number of work at step 1 at index 1. Okay, so let me see if I'm getting this correct. dir and steps. Yes. Okay, then what should we do? Then I think for each of these steps I need to calculate something. So there is a for loop for every step from 0 until the step is less than the steps that we have, and as I'm adding to this step I need to do three things. First, I need to move the head according to not move according to direction that I have here. So this is step 1. Step 2, I need to update the tail, and step 3, I need to update the path accordingly. Okay, so let's go and write these functions. But before that I will have like three different variables here so that I can manipulate in the functions. One is the head, one is the tail. I'm starting at 0 and 0. It doesn't matter, you can start at whatever position you like, because the position of these doesn't really matter in the end. So this will keep the position of head and this will keep the position of tail. I will need to store the path as well. So how can I do that? I can do that with an array and then check if that is visited or not, but I think I will go with a dictionary. This looks like much more simpler, because I want to do something like this and say in the beginning it's 0 and 0 and the value is true, and every time the tail changes I will update this value. I might overwrite the values inside, but it doesn't matter because I'm just updating this, and in the end I will just get the list of the items that are inside this dictionary or in this object. Okay, so step first, we have the move head function, which of course is a constant, and it will receive a direction, and based on direction I will have a bunch of actually four of them. So up and then down and then right and then left. Okay, for every one of them, if I am going up, I need the head at index 0 to be decremented. Actually, let me do this. If I'm going down, the head at index 0 should be incremented. I'm going right, the head at index 0 should be incremented. And if I'm going to the left, the head at index 1 should be decremented. Okay, this is fine. Next function is, I will test this after writing these two. So I will update the tail. This is for now an empty function. And then update path. This is also an empty function at the beginning. So const these two. Then let me do this, and then I will say something to check that. So move head up a bunch of times and then right, and then tell me the head. how did the head end up? So yeah, so we are going 3 steps up and 1 step to the right, which is correct. So if I say I'm going up and then down and then left, it should be 1 and -1, yes. So I'm going up, then I'm going back to where I was, and then I'm going down and I'm going left. Okay, so this is working fine. The next step is the up. Let me write update path first because this is the easier part. So I would just update my my tail, no, my path according to tail. So I would say give me the tail at position 0 and tail at position 1 and then set that to true. This is done. This is okay. Update path. Yeah, this is this. Okay. So we are okay here. I just need to update my tail accordingly. So for the tail, if they are 1 apart in both direction, I don't need to do anything. I don't need to update the tail from what I understand. So yeah, so if the space is 1 only, then it's fine. Okay, so first I will check if they are 2 apart in one direction and 0 on the other. So if I can find a simple one here. So something like these two. I'm writing these two. So I would say the absolute value of head at index 0 minus head minus tail, sorry, minus tail and index 0, if this absolute value is 2 and not the absolute value, and the head at index 1 is the same as tail at index 1, then the thing that I should do is like I will just update the tail at index 0 and I will add to it the floor of head at index 0 minus tail at index 0 and then divide this by 2 and the floor of that. So I am subtracting these from these to get the difference, then I'm dividing the difference by 2 and then add that to the tail. Okay, so if like for example they are in 3 and 1, so 3 minus 1 is 2, 2 divided by 2 is 1, and then 1 added to the tail. Okay, so this is fine. Now I need to do the same the other way around. So if head 1 and then tail 1 are 2 and head at index 0 and tail at index 0 are the same, then tail at index 1 should be head at index 1 minus tail at index 1 divided by 2. Right? Now we should get to the tricky part. Let me do this with else so that it skips if one of these happens. It doesn't check the other one. Else if this is the bigger one. So this is like 2 in one direction and 1 in other direction. So I would say if math dot absolute value of head at index 0 minus tail at index 0. I could do this the other way around because I'm using the absolute value, it doesn't matter, but I'm doing it like this, so I'm staying the same all in all the places. So if this is greater than 1, so it's 2, we could say 2 as well, or the same thing on the other direction. So if head 1 and tail 1 are 1 apart, if other one of these two has happened, we are diagonally apart. Diagonally. Then I need to update both of them. So tail at index 0 plus equals the floor of head at index 0 minus tail at index 0, and then divide this by math dot absolute value of head at index 0 minus tail at index 0. And for the other one, tail at index 1, I will do the same with index 1. So if we are in a situation like this, then the tail should be moved 1 here, which is the to be in the same direction as the head, and it should go 1 up. So I'm adding to the tail this value. Okay. So it will obviously add them 1 in the direction that is needed. It will always be 1. But sometimes it's -1 and sometimes it's 1. Based on which one is bigger in which direction we are. So I think this is fine. If I explain it more, it will be more complicated, but you can figure it out later on by your own. So okay, so I think this is pretty much it. I have confidence in my code, and you know what? I will just get the path. Yes, I think I'm getting the correct path. 1 4 2 4. Okay. To make sure, I need to get the path on the object and then to get the length to get the number of the items that I have there. I hope it's 13. Yes. So they say that we should get 13. Right? There are 13 positions. Okay, let's update. Let's test it with the input puzzle, which is obviously a huge one. If I'm copying it here and pasting it here, I'm getting 60 30. So let's see that. Yes, we got the gold star number 1. Let's go to the second part then. Okay, so for the part 2, it gets a little bit tricky. A rope snaps. Suddenly the river is getting a lot closer than you remember. Okay, the bridge is still there, but some of the ropes that broke are now whipping toward you as you fall through the air. Okay, wow. Rather than 2 knots, you must simulate a rope consisting of 10 knots. Okay, so this is going to be the same as the old snake game that it was like ages ago. Okay, close the knot in front of it using the same. Okay, so for example, knot 1 is tail for head and it's head for knot 2. Then this is tail for this one and head for this one, and we go along until the end. Okay, so there are 1 head and 9 tails, or 9 bodies, so to say. Okay, so this is like this, and this is moving. Yeah, so we are getting to 4, 6. Aha, 7, 8, and 9 are also here because it's not getting, the head is not getting far apart. Okay, okay. Pretty much the same thing, but I think with only 10. So now you need to keep track of the positions of the trail number 9. Okay, the last one in the knots array or in the knots list. In this example, the trail never moves. Yeah, because it's always here. And so it's only visiting one position, which is the starting position. However, be careful more types of motions are possible than before, so you might want to visually compare it this one. Okay, this is another test, and wow, this is getting crazy. Yeah, this is moving. Okay, it's almost like a half heart shape. Okay, how many positions does the tail of the rope visit at least once? So basically, I'm going to have a array of 10 knots instead. Let me copy paste it from here to here and make some updates there. So instead of head and tail, I will have an array of 10 knots. The path updating is basically the same. Updating the tail should be the same. The only thing is that I should have 10 knots. Okay, so let me say, instead of that, I'm saying knots, and knots is a new array of length 10. I'm including the head as well, and then I will fill it with anything that I like, and then I map it to be each of them to be at position 0 and 0. Okay, the direction is the same, but when I'm moving the head, I will just get the head first. So I would say head is knots at index 0. Then I'm updating that. So this is done. This is nothing special here. So I will come to these later. So I need to see what I'm going to do here. Okay, so for each step, what I need to do is first move the head in that direction and then have another for loop for the rest of them. So for index, I'm saying it's not for every knot in the array while it's less than 10, and I'm adding to the knot. Just do these two. For the sake of naming, I will change this to update not like this, and I'm giving it the not to know which one I'm changing, updating, and to have the reference to the head of that not. So if I say update not number 3, then in the update I will get 2 as the head and then do the same uh, updating. Okay, so this should be the way it goes here. I'm just moving the head and then updating the not according to not position and then updating the path. Updating the path should be the tail at index, not the tail, the not at index, nots at index 0, index 9 and 0. I cannot speak today. And then the nots at index 9 and index 1. Okay, this is the same. I'm just updating the last one here, and I'm updating tail. I'm just doing it for head and tail, and I'm just getting a not value here, so I can have my head and tail here. So I would say head is the previous not, so the head is not at not -1 at the index before that, and the tail should be not at that index, and the rest are just following, so they follow each other. Update tail, nice, update not. This is update not. So this is the same, the logic is the same. I'm just updating the head and tail here, and I'm moving the head as usual and updating the path as usual. Okay, so let me test with the first one, which was the smallest one. Where is that? So with this one I should get 1. Okay, I'm going to let me check it again before running it. This is fine. Oh, I need to have it from not number 1, because if I'm saying 0, then here the not before that is not defined. So this should be okay. I'm getting 1 correct. Then I need to go down and find the other input, which is this one. This should give me what? 36. Yes, this is correct. And hopefully it's the same with the big data. So like this, and if I save and I do this, I will get 24, 44, 45, 2545, 2545, and yes. So thank you for today. Please like and share and subscribe to my channel if you find my content useful. Thank you again for watching, and see you tomorrow.